Let's go over the product property of logarithms in this video. This is my second take. Okay. I like to make up my own example. Say that you have natural log of 3 times x. 3 times x. You can separate this as natural log of 3 plus natural log of x. So if you have a product 3 times x, you can separate this as 2 separate log. Both of them will have to be natural log, but you can separate a product into a sum of separate logs. So, and you may be wondering, like, what's the point of making it longer? Because I guess condensing it makes more sense. You have a long expression. For example, if you have log 3 plus log 4, you can simplify this as log 12. And if you're wondering, where did you get 12 from? I did 3 times 4 to get this 12. So it makes sense what we just did with this red pen. Okay, how the left side became this right side. This is called condensing. If the direction is asking you to condense, you're trying to make this into a single logarithm. So you multiply the arguments and write this as a single logarithmic expression. But what is the point of what I did up here? Like, why would you break down a perfectly fine-looking single log expression into a sum of 2 separate? Well, later on, when you guys go up to calculus class, being able to separate a complicated looking, well, 3x is not that bad, but say that you got a product of, some stuff. It's easier to deal with each of these pieces instead of a product of all of them. So what I just did up there with this black pen is called expanding. So Alex, this week, your homework will ask you to do both way, expand it or condense it. But we're still using the same formula, or I think they call it property. Product property of logarithm. What it is saying is, let me go ahead and box this theorem. Log base b of x times y can be broken down into log base b of x plus log base b of y. And let's see, I know, it used to be multiplication, right? But you're separating them with the plus sign in the middle. But you've seen something similar to this before when you studied properties of exponents in algebra class. For example, I'm going to go over this green tip. Remember when you had x squared times x to the third power? Okay, what did you do if you were to simplify this? When two factors of the same base are multiplied, the base is x, the base is x. If you're multiplying these two, then the base is unchanged. So the other side of the equal sign, the base will still be x. But what do we do with the exponent? We add the exponent. So if you do 2 plus 3, you get x to the 5th power. So this is the property of exponent, right, that you learned in algebra class. And this is true because x squared means you're multiplying x times x. X cubed means you're multiplying x times x times x. So if you multiply those two together, you're multiplying x by itself how many times? 1, 2, 3, 4, 5 times. So this is true. When you are multiplying powers, you added exponents. So you know how logs and exponents are related, right? They're inverse of each other. So this rule, this is the underlying principle for the product property of logarithms. So let's take a look at this. Example A is asking you to write the expression as a single logarithm. What you need to check first is if they have the common base. This is log base 2. This is also log base 2. If they are the same, we can combine it and we can condense it into a single log. If they are not the same base, then we cannot go further. If that number was 2 and the other number was 5, like I'm talking about the bases, then we can't combine these. So because they have the common base 2, I will go ahead and write this as log base 2 of Now I need to multiply these arguments. You have to do 3 times 4. So the new argument is 12, not 6. Okay, so that was one example. I have some room on the side. How about I give you a couple more of these? Okay, a couple more of these. That's an example of us just looking at a sum of 2 logs, but you may have sum of 3 logs too. That's okay. So what if you have, let me make up an example, okay? B. You have natural log of 3 plus natural log of x. Stop it. X, let me move it. I may have to erase this too. Plus natural log of y. Say that you have this. First of all, they are all natural log, right? They're all natural log. They have common log base of e. Okay? Natural log, all of their bases are e. So they're all connected by plus sign. So I can rewrite this as a single natural log. Whoopsie. I can write this as a single natural log. But what do we do with these arguments? 3 and x and y. We need to multiply those 3 together and get 3xy. So sometimes they will ask you to expand it, which means go start from here, separated these out. But I think, you know what, let me go ahead and give you that example for the last one. I have one more room. How about if you have something like this? Log of, I guess I can't be too creative. Let me just go ahead and give you 5x, okay? What if you have log of 5x and you're trying to expand this? You can write this as log of 5 plus log x. Make sure you have a plus sign in between them, but that is how you can use the product property of logarithms. The next video, I will go over the quotient property of logarithm. If product can be broken down as a sum, what do you think we can break down a quotient as? So we will look at that one in our next video, and I have a couple more examples to show you on that one.